Okay, welcome America, welcome India, and welcome Taylor Swift. Booyah, Friday. Today we are going to do a few problems for review on the polygon unit. And we're going to start with some properties of parallelograms. So, welcome. All right, so find the value of the variable in the parallelogram. So we're going to start with number 8. First thing we know about one property of parallelogram is that the diagonals bisect each other. So this diagonal is bisected, which means that M is going to be equal to 10. There we go, no work. This diagonal is a different length than this diagonal. Okay, the diagonals aren't congruent, but it's still been bisected, cut perfectly in half. So you'd set n minus 3 equal to 8 and then solve for n. Any questions on that? That means you can also do number 9, and then this c plus 5 is the length of this segment. It's kind of hard to see. And 11 is the length of this one, and then 14 is the length of this one, and d plus 4 is the length of that one. Good? Okay. So now we also, in a parallelogram, we also have opposite angles are congruent. So we can set b plus 16 equal to, that's an equal sign, not a z, 103. Are we good? We also have opposite sides. They're parallel, but they're also congruent. So we can set a minus 10 equal to 18. Are we good? Any questions on 8 through 10? Yeah?
You're missing a variable of 18.
Oh, what's the variable that I'm missing? Where's C?
It's in the top right.
Oh my gosh, that's a weird place for C. What even is that? The measure of the angle? Let's go with that. That would make sense. You know what I like? I actually like that. These lines are parallel. If this is our transversal, the measure of this angle is 103. What are these types of angles called? Thank you. Consecutive interior angles. Consecutive interior angles are always what when the lines are parallel? Supplementary. So there's how to find C. And there should be a degree sign there, and that C should be closer to the angle.
I actually did it a different way where I just took the two other angles out between 103 and then b plus 16 equal 103. Then I just took the other two. I just took what numbers were left and I just divided it by 2 and that's the angle.
Yeah, because they all have to add up to 360. Brilliant. Love it. Because if that's C, that one's C as well. So C plus B plus 16 plus 103 adds up to 360. So he solved for B, and then he said, well, whatever's left, I'm just going to cut in half. Love it. Love it. All right, let's move on. We're skipping number 12, but look at number 11. Do you see how we are told that we've got one set of parallel sides, which makes it a trapezoid, okay? And then we've got the legs are the same measure. Okay, they're congruent there, which tells you it's what type of trapezoid? Isosceles, yeah, and it's okay if you don't, spell it right. No, it's fine. And it's an isosceles trapezoid. Because it's an isosceles trapezoid, the base angles theorem applies here. Think of this as a triangle. The base angles theorem says those sides are the same length. The angles opposite them are also the same measure. So this base angle is 50 degrees. This angle is also 50 degrees. And I think that's all you're looking for in that problem. Okay. And I have one more type of problem I'd like to show you. The kite problems, okay? Kite has 4 sides, so it is a quadrilateral. So the sum of all the interior angles is 360, right? Now, if I draw a line right here, okay, that's a line of symmetry. It's on a piece of paper, and I folded the triangle over top to the bottom, right? See, it's a symmetric figure. that makes the measure of this angle equal to the measure of this angle. So if I call them x, they're both going to be x because they're both the same. We have x plus x, which is 2x, plus 100 plus 40 should all add up to what?
360.
Yeah, and that's how you solve for x. Good? You're not supposed to know what that is because I cut that out because I didn't want you to have it. So that's why it looks a little funky there. But you know that angle's 60, that angle's 80, and that's it.